So today we will learn about multiplication and division of complex numbers in Cartesian form or standard form, which is a plus z equals a plus bi, all Cartesian or standard form of the complex number. Later on we will learn about the polar form of the complex number. But today, and there will be different ways to divide and multiply when complex number will be in the polar form. But today we will learn how to multiply them and divide in the Cartesian form. Let's consider it on the example. Because multiplication is very straightforward. You just pretty much expand brackets. For example, multiply. We have complex number z equals 3 plus 5i, and we have complex number u equals 1 minus 4i. And we need to find the product zu. That will we just need to expand the brackets. 3 plus 5i times 1 minus 4i. We expand brackets, 3 plus 5i minus 12i minus 20i squared. 3 minus 5i minus 12 minus 20i squared. Collect like terms, and I squared is negative 1, so this becomes plus 20, so we have 23 minus 7. Pretty straightforward. Now, when two complex numbers are equal, let's say if we have z and complex number z and w equals c plus di. If we have z equals w, that implies that a equals c and b equals d. So only then they will be equal. So let's consider the next example. So if we have the next question, 2 plus 3i times a plus bi equal 16 plus 11i. And we need to find a and b. So we need to expand these brackets. So we have 2a plus 3ai plus 2bi plus 3bi squared equals 16 plus 11i. We collect real part together, which will be I squared is negative 1, so this becomes negative 3b. So you get 2a minus 3b plus 3a plus 2bi. Just collect the real part and imaginary parts together, equals 16 plus 11i. Two non-complex numbers equal, that means their real parts equal, so 2a minus 3b equals 16, and imaginary parts are equal, 3a plus 2b equals 11, and then we just solve two simultaneous equations. Let's say multiply first equation by 2, second equation by 3, to equalize coefficients of b. So we have 4a minus 6b equals 32, 9a plus 6b equals 33. Then when we add, b is eliminated, so we get 13a equal 65. So a will be equal 5. Then substituting it back into any of them, let's say into this one, we have 10 minus 3b equals 16, and as you correctly said, b equal negative 2. Make sense? Now, division of the complex numbers. To learn how to divide complex numbers, we will need to introduce one new concept, conjugate. If you have complex number z equals a plus bi, conjugate denoted with a z with a dash on top. And that means same real part, but opposite sign of the imaginary part. A plus bi, conjugate a minus bi.
Or like rationalizing.
Yes, very good guess. So, let's see what will happen if you multiply complex number with its conjugate. So if you multiply z times conjugate, we have a plus bi times a minus bi. So will be equal a squared minus b squared I squared, which will become a squared plus b squared. So when we multiply complex number with its conjugate, we get a real number. It's a real number. And that we will use to divide complex numbers. For example, let's divide 3 plus 5i divided by 2 minus 3i. We need to do this division. We need to make denominator as a real number. So we need to multiply both numerator and denominator by conjugate of the denominator.
Like get rid of I.
It's like when we rationalize that.
So I is the root that we're getting rid of.
Yeah, we need to get rid of the complex number, so we put I in the denominator. So 3 plus 5i times 2 plus 3i over 2 minus 3i times 2 plus 3i equal, expanding brackets in the numerator, we have 6 plus 10i plus 9i plus 15i squared over 4 plus 9 equal 15i squared minus 15, so we get minus 9 plus 19i over 13, so final answer is negative 9 on 13 plus 19 over 13i. So that will be the answer to the division. We got it into the standard form, a plus bi. Make sense? And one more example involving division. For example, we need to simplify the next expression. 2 plus 5i squared times 5i minus 2 divided by 3 times 4 plus 7i minus 2 times 5 plus 8. Simplify. To do that, we need to expand brackets collect like terms. So we have, by the way, should we square this and times this, or we can do it in more smart way? Can you see the
Square.
yes, difference of two squares? So if we rewrite this as 5i plus 2 times 5i plus 2 times 5i minus 2. So I rewrite this as 5i plus, because 2 plus 5i is the same as 5 plus 5i plus 2. So then we will have the difference of two squares, which will make it easier. Here we just need to expand the brackets. 12 plus 21i minus 10 minus 16i equal. So 5i plus 2 times 5i minus 2 will be 5i times 5i will be negative 25, because I squared equal negative 1. So we have 5i plus 2 times negative 25, and we have minus 4. And here we have 12 minus 10, we have 2 plus 5i. No, it cancels out. So answer is negative 29. So makes sense how to multiply question? Makes sense how to multiply and divide complex numbers in Cartesian form. Okay, that's all new stuff for today. Like, subscribe, and donate to help fight terrorist countries and organizations, Russia, Iran, etc. Support Ukraine and Israel.